I'm honored that Purdue's Krannert School of Management has been chosen as one of the finalists for UPS's George D. Smith Prize. I'm honored but not surprised. At Purdue, we've created a thriving ecosystem that fosters the best of operations research practice. Knowledge from that cutting-edge research is passed along to our students both in and out of the classroom. Through case competitions, research projects, and faculty-led corporate consulting opportunities, our students learn both the how and the why of data analysis. In so doing, they gain the ability to use data to tackle complex business problems and create innovative solutions. Our expertise in operations management and data analysis has long been recognized. For the past quarter century, Purdue has been ranked in the top 10 schools for operations management by U.S. News and World Report. CIO magazine named our business offering in business analytics and information management the #1 data science program in the country. Enrollment in our analytics-based majors has skyrocketed at both the graduate and undergraduate level. We're proud of the faculty, staff, students, and alumni that have helped us gather recognition in operations research. We believe Purdue prepares tomorrow's analytical leaders, and we look forward to carrying that tradition on for decades to come.
You just heard from Dean David Hummels. My name is Anant Iyer. I am the department head for the management department at the Krannert School of Management and the senior associate dean here at the Krannert School of Management. Our team consists of 4 other faculty in the management department: Professors Annabelle Feng, Mohit Tawar Malani, Amy David, and Matthew Lanham. Each of them is going to talk about their role of responsibility in the programs. You'll hear a lot of detail from them as this video progresses. I'm here to talk about the analytics journey of a student at the Krannert School of Management's management department. In particular, let's start with the undergraduate program. The undergraduate program consists of a number of different majors that students choose from. Of those different majors, we will focus on 2 specific majors: the Business Analytics and Information Management major and the Supply Chain and Operations Management major. These are the 2 areas within the management department that we will focus on today in order to learn about how students receive information in the classroom, opportunities for projects and experiential learning, and the faculty member in front of the class and their role in translating their research into content that's presented in the classroom. Krannert School of Management was formed in 1959 with faculty from the schools of Engineering, Education, Science, and Humanities. Back in 1961, 95% of the 80 students who were in the BS in Industrial Management program were transfers from the School of Engineering, and the focus was on training engineers to become managers. This training included partnerships with companies, co-op opportunities, industry speakers in all parts of the programs. In 1988, the Center for the Management of Manufacturing Enterprises was launched. Today, we have 2,800 undergraduate students in the School of Management across all years, and majors in Supply Chain Operations Management and Business Analytics and Information Management have grown from 190 students in 2019 to 220 in 2021. 20% of the students graduating take jobs in operations, consulting, and analytics. The MS Business Analytics and Information program started in 2017 with 20 students and now has 81 students and more in 2020 onwards. The MS in Global Supply Chain Management program has about 55 students today in 2021. Online programs in BAIM and GSCM have grown from 20 to 40 students over the past year. We also have a doctoral program in quantitative methods and global supply chain management, which has 14 students across the years. You'll notice that we have a substantial footprint regarding the student base at the undergraduate, master's, and PhD level, and all of these students get exposed to training in analytics. We'll now talk about the DCMME Center and project opportunities for students at the center. The Dauch Center for the Management of Manufacturing Enterprises, also known as DCMME, was launched back in 1988. This suggests a long history of engagement with manufacturers in the management department. The goal of the center is to bridge students, faculty, and industry in order to create opportunities for collaboration. The center hosts conferences showcasing projects done every year, and students get opportunities for paid internships with projects and with industry. Examples of projects we've done in the past include projects with Procter & Gamble, with the U.S. Coast Guard, with the U.S. Department of Energy, with Indiana's Department of Transportation, with funded grants from the Lilly Endowment and Connexus. The main role of the center is to provide students the opportunity to make a business case for analytics use in solving operations and supply chain problems. We'll focus on one specific project because it covers a variety of tools, problems, and contexts. I'd like to now talk about the Indiana Department of Transportation project. The focus of the project was to answer two questions. Should truck replacement decisions, that is the age of their replacement, vary by region to minimize total costs? And second, would route changes for the truck deployment reduce overall deadhead miles? Tools used include exploratory data analysis, piecewise regression, math programming, optimization, and simulation. Indiana is divided into three regions, the North, the Central, and South, with different climate zones. If you look at the overall cost of operation, the cost of operation is higher in the Northern region, lower in the Central than the South. But if you look at the details, you notice a puzzling pattern that the costs are lower in the North versus the Central versus the South for low mileage trucks and higher with North, Central, South for the high mileage trucks. This can be represented as a piecewise linear representation of cost versus age, which correspondingly generates different optimal ages for replacement. When we look at the empirical analysis, that generates the optimal decision of replacement being 9 years for the North, 10 in the Central region, and 13 in the South. This is an interesting approach to use empirical data to inform optimal replacement. We'll now talk about snow route optimization for INDOT across the 6 districts. And this is the deployment of the 1,079 trucks. The first analysis we did showed that across the 3 regions, there were between 12% and 23% deadhead miles, which is miles driven without picking up snow. They also had sensor data on vehicles that would provide click-throughs of the position of the trucks, which was analyzed to figure out actual routes. We came up with 4 approaches for snow route optimization, and each of them put in different levels of constraints. They explore the impact of changing the location of the shelter. They explore the impact of changing routes. We built a math programming model that allowed all these different solutions to be explored, and it generated results which were pretty substantial. The numbers, the fraction of deadhead miles decreased, varies from 62% to 31%. The summary of this project is that the models and the data allowed INDOT to get a solid foundation for our recommendations. Implementation and documentation of savings were provided in reports, and all students who worked on this project were acknowledged in the report as co-authors, and they used these project reports to go out and seek jobs. As mentioned before, a variety of tools were used in order to solve these problems. You'll now hear from Amy David. Amy is a clinical associate professor in the supply chain operations management area in the management department. Amy's responsibility as academic director of the MS in Global Supply Chain Management include all aspects of curricular development, student success, and ensuring that the program curriculum is synchronized and using the best tools available currently.
Analytics drives our research, curriculum, and industry collaboration, which in turn drive our student outcomes. Our students are taught advanced analytical methods and their applications in supply chain. They take this knowledge with them into case competitions, sponsored industry projects, and their post-Krannert careers. Our supply chain curriculum focuses on intensive understanding of analytics tools as applied to many different areas of application. Students take a specific course in supply chain analytics and learn many other tools in their core courses, including simulation, machine learning, and optimization. Using various methods such as these, students get a firm grounding in descriptive, predictive, and prescriptive analytics. Students have many opportunities to apply these tools to a variety of different supply chain areas. We offer a wide breadth of supply chain courses beyond the basics of operation and supply chain management. Through dedicated courses in logistics, strategic sourcing, global strategy, and service operations, students are able to explore various career paths for employment and experience firsthand how analytics can be used to not only solve supply chain problems, but to create real business value for an organization. Krannert students have won awards at many case competitions run by industry groups, including Connexus Indiana, Association for Supply Chain Management, and Council of Supply Chain Management Professionals. Most recently, a team of Krannert graduate students participated in the case competition held by the CSCMP Chicago Roundtable. The competition asked students to analyze a large data set from a retailer that had seen a major demand decline during the early months of COVID, and to recommend a sourcing and inventory strategy for the post-COVID recovery. The team from Krannert won the competition as judged by professionals from competition sponsors SAP, Molex, Signode, and Supply Velocity. The winning team was invited to present their solution at the CSCMP EDGE conference. Tina Lin and Ahmed Ali, students from the winning team, describe how they used their course learnings to approach the case.
In our approach of tackling this case, we first utilized Pareto analysis to understand different categories of the products that the company was carrying. By lowering service level, the company was able to achieve higher profit with lower carrying costs as well as lowering their risk.
Throughout this case competition, my team and I used analytics to be able to conduct effective A/B analysis on SKUs that were presented throughout the case material or the case competition. We used multiple supply chain analysis methods to understand more about the trends that were set throughout supply planning of the material of this of the material that's used within these SKUs. This included and was not limited to linear programming, retrospective analysis. We use these methods to understand more about the service levels that our subject was trying to achieve and provide the correct recommendation. So we actually learned about retrospective analysis in our supply chain management class with Professor Zon Pang, and we learned about linear programming in Professor Will Haskell's supply chain analytics class. So we utilized these analytics methods and employed multiple models in Excel to be able to come to a data-driven decision about the recommendation that we're going to give.
Experiential learning projects are a core part of our curriculum, with every student completing either an internship or an industry project with one of our partner companies. Our partner companies know that Krannert projects create real value for their organization. Gary Smith, Continuous Improvement Manager at Caterpillar, was particularly impressed by our students' ability to operate with limited data and create useful general models. In the fall of 2021, one team of master's students did a project for Gain Systems, a leading provider of software for multi-echelon inventory management. The team was tasked with creating an algorithm that would predict missing weight data in item masters, allowing for more accurate freight calculations. Team member Shibasis Mohapatra discusses that experience.
A typical data science approach where we source the data and we apply different kind of data manipulation techniques, like we do EDA, which is exploratory data analysis, using different ETL tools. And after that, we calculated, we saw the potential outliers, because the incorrect weights that we took into account was the outliers, and the missing weight was something that needed to be treated using imputation. So we established a baseline. After we established a baseline scenario, what we did was that we basically came up with multiple algorithms, like to calculate the incorrect weight using outlier. You need to first detect the outlier, and that can be done through IQR method. That is one of the method. And to treat those outliers, we had different algorithms like KNN, DBScan. We basically took different algorithms and we did the modeling using R. And after that, we found the accuracy of those models. And this is basically the approach that we followed, that, from the data manipulation to baseline, and then creating a model, and then finding the accuracy of those models, and finally, coming up with the recommendation.
Another fall 2021 project was for MES Inc., a longtime partner company and full-service provider of global manufacturing and supply chain management services. MES wanted to determine their cost exposure they would face if they guaranteed parts in stock for their customers. One team member, Harsha Misra, recalls their work.
Hello, my name is Harsha Mishra. I'm a student in MS Global Supply Chain Management program in Cranard School of Management, cohort December 2022. I had an amazing time last year in the fall of 2021 working on the Experiential Learning Initiative by Cranard. We worked with MES Incorporation, an ISO 9001 certified company which sources its manufacturing from India, China, Taiwan, Malaysia, and Vietnam. Along with that, MES is also a full service provider of global supply chain and manufacturing services. We consulted MES on the number of parts for which zero air freight guarantee can be provided to its customers. We also analyzed the cost related to these SKUs. We used at-risk for the same. I had an amazing time collaborating with the team of 5, a very supportive advisor, Professor Amy David, as well as the client. Overall, it was a great learning opportunity.
Cranard's Masters in Global Supply Chain Management students have obtained positions at some of the top supply chain employers, including Amazon, Apple, Walmart, Dell, and more. One of these graduates is Raj Buddharaja, who graduated in December of 2021 and now holds the role of Pathways Operations Manager at Amazon.
Currently, I am working for Amazon as a Pathways Operations Manager at an Amazon Robotics Sortable Fulfillment Center. My master's in Global Supply Chain Management and my prior professional experience prepared me for this responsibility. Several of my capstone courses for my major tied directly into the work I have been doing on the job. For example, my process path optimization has tied in directly with my current project as we are seeking to optimize the standard work in the shipping dock. And of course, working in team projects during my course has helped hone my people management skills, which is a big part of my job.
Analytics is a critical tool for designing, operating, and managing supply chains, and our analytical focus has given our students a firm foundation as they interact with the business world. Through their successes in case competitions, industry projects, and postgraduate employment, it's clear that analytics is driving excellent student outcomes here at Cranard.
You'll now hear from Matthew Lanham. Matthew is a clinical assistant professor in the business analytics area in the management department. He's also the academic director for the Master of Science in Business Analytics and Information Management.
The MS BAIM program began residentially in fall 2016. It's an intensive 11-month, 36-credit-hour STEM certified program that runs June through May. The curriculum is split 50-50 among quantitative methods and MIS faculty to ensure a well-balanced mastery of both methods and tools. Integrated throughout the curriculum are professional development activities that either tie directly to a course or after students have completed a certain set of courses. We offer a unique approach to experiential learning that stresses communication and engagement in professional communities. I often tell program partners and recruiters that if you put business analytics programs on one end of the spectrum and data science programs on the other, the MS BAIM program would be the closest to data science you would find among analytics programs housed in a school of business. While Python is the technology used the most in our courses to do the work, several other tools and software are used throughout. While students gain experience with the technical aspects of those technologies, the decision-centric business focus is never lost, and students are challenged in nearly every course to articulate their results via team project presentations. Students must also complement our deep technical assortment of analytics courses with business electives from any area of their choosing. Integrated throughout our curriculum are professional development activities that either tie directly to a course or after students have completed a certain set of courses. We have a wonderful partnership with SAS, and every year we have their trainers hold certification boot camps for us. Many of our students have become certified as a SAS-based programmer and SAS statistical business analyst. Other certifications many of our students have achieved is the Tableau Desktop Specialist and Oracle Database SQL Associate. We just recently added 2 new 1-credit-hour, low-stakes cloud computing courses that focus directly on the new tools and skills needed to pass the AWS Certified Cloud Practitioner and Solution Architect Associate. Students also prepare for the Informs CAP exam in their final semester industry practicum course. Beginning in 2020, we held the SAS Optimization Challenge, where students get 2 days of intense optimization training and are challenged to solve an optimization problem and present their analysis as a team for financial awards. This event has been key to keeping true to our decision-centric theme throughout our program. The program culminates in the spring with the industry practicum course. All analytics programs offer some form of experiential learning experience, but we find our approach is much more tailored to the student's needs and the partner needs. For example, October through December, we provide students a comprehensive survey where they tell us what they did prior to Purdue, their goals post-Purdue, and if they have had any particular problems that they'd like to work on. We then ask our partners what problems they would like to have the students work on beginning in January for 12 weeks. We are then tasked with playing matchmaker to make sure we create an experience where we get skin in the game from both the partners and the students. We have cultivated a large list of partners over the past 5 years. We don't work with each partner every year. It's completely dependent on the problems that they have and the students' interests to make sure that we maximize the student story to get them where they want to be post-graduation. The 12-week industry practicum team projects are mentored by myself and my colleague, Professor Yang Wang, who comes from the MIS area. During the project, all teams have required readings from the Informs Analytics Body of Knowledge. They are also following the 7 Informs Certified Analytics Professional Job Task Analysis domains as they develop their solution. The key here is getting the master following the process, asking the right questions, and the ABOC provides a lot of nice examples of things they might not have covered in their core courses that they can consider for the problem they are tasked with. Another unique aspect about this experience is students are doing other activities and getting feedback from communication faculty to help them better present, write, and articulate their work with their client. So it's not just analytics faculty, but another set of trained eyes and perspectives to help students improve their work as they go along. Lastly, towards the end of their project, all students meet with our Krannert Professional Development Center career coaches. The coaches have read the project scope and they drill the students on why does the work really matter to the organization, how do you communicate it to a more general audience, and making sure that they make it crystal clear what they bring to the table to employers. These 3 different sets of eyes are key to developing our students and setting them up for success later at the professional conferences and in interviews. Our partners have noticed every year 100% of our partners want to collaborate with us again the next year. During the 12 weeks, we make sure students are submitting their abstracts and working papers on time to professional conferences where Informs Business Analytics is our go-to. Our entire timeline is planned around that conference. Some teams also submit their work to other venues, such as PyCon, Open Data Science Conference, Midwest DSI, among others. The first year of our program, we sent 15 students to the Informs Business Analytics Conference in Las Vegas, and we had 5 poster presentations. 100% of the MS BAIM attendees felt it was the most professionally rewarding experience during their program. The following year, we sent 23 MS BAIM students and they presented 12 posters. In the 2019 conference, we had 19 posters presented and our teams won both first place and third place in the student poster competition. 25% of our student job placements also came from the conference that year. In 2020, we had 16 posters accepted for presentation and 80 students funded to attend, but the conference went virtual due to COVID-19. In 2021, we had fewer students due to the COVID-19 international travel restrictions, but still had 5 posters presented and 19 students participated. That year, we also won first and third place in the student poster competition. Since our program began, we have invested over $150,000 into our MS BAIM students to get them more involved in Informs because we believe in the community and the long-term value it provides analytics professionals. In December 2021, we started funding for Informs CAP examinations to try to get more of our alumni certified. We believe a CAP is more likely to stay engaged in the community compared to a non-CAP. As we have grown the program steadily over time, we have also improved the quality and student outcomes. Since 2019, we have achieved almost 100% placement every year. We are especially proud of the 97% we achieved in 2020, given the challenging job market due to COVID-19. Even during that year, we managed to improve our average starting salary to $97,000. Being an academic program, we have to care about the ranking systems, and our program has remained consistent and top tier since we started. Probably the most well-known and most respected rankings come from the U.S. News and World Report, which has ranked us number 9 since it began ranking analytics programs. Another measure of quality and outcomes, besides placement statistics and rankings, is how our students are doing in their careers. We sent a survey to all MS BAIM alumni over winter break and achieved a fantastic 59% response rate from them. We found since their first job placement, 3 years out, the median change in salary was almost $23,000. 5 years out, they had increased their salary on average $62,000. We are seeing not only a growth in their income, but responsibilities and titles in their organizations. Another thing I think is very important is what the alumni think about our program today, not necessarily right when they graduated. 96% of our MS BAIM alumni were satisfied with their decision to attend this program. That's the statistic that I'm most proud of as the academic director, because I believe it really measures the strong foundation in analytics they received in our program and can attest to it in their professional lives today. The MS BAIM program is the industry leader in analytics education. We live and breathe by the science of better.
You'll now hear from Professor Annabelle Feng. Annabelle is a chaired full professor in the supply chain operations management area. She's responsible as area coordinator for ensuring continued success of the area in research, teaching, and engagement with industry.
Research, industry collaboration, and educational programs are the gears that keeps our academic area functioning, and our strength in analytics is the engine that runs the gears. In the supply chain and operations management area, an elite group of faculty members here at Purdue are dedicated to research, practice, and education. Our faculty expertise covers a wide range of methodologies, including statistical machine learning, optimization, stochastic model, experimental design, game theory, and econometrics. We also have faculty expertise cover a variety of application domains, including manufacturing planning, inventory control, dynamic pricing, logistics design, supply chain negotiations, hospital operations, healthcare service delivery, ethical and sustainable operations, project management, marketplace and e-commerce, and sharing economy. Faculty are the drivers of not only theoretical and applied research, but also industrial collaborations and educational programs. Analytics is the blood running through everything we do here, building our strong reputation in research and programs. The supply chain and operations management area at Purdue has a long reputation for highly quantitative and rigorous research. On the theoretical front, a heavy emphasis of faculty research is to develop and integrate statistical machine learning with stochastic modeling and optimization techniques. On the application front, our faculty have extensively collaborated with private, public, nonprofit organizations, both locally and internationally, to design and implement solutions that have generated tangible practical values. Industry collaboration is always a source of inspiration for research and teaching. Our faculty are dedicated to understanding the practical challenges and developing new methodologies and implementable solutions to resolve the puzzles faced by the practitioners. These collaborations bridge the gap between theory and practice, generating tangible practical values and leading to advancement of the theory. They also allow our faculty to bring the latest knowledge and experience into our classrooms, passing them to the future business leaders. Certainly, the root of success is the strong methodological capability of our faculty. Our faculty members have been recognized for their research contributions to both theory and practice with numerous awards and are actively serving editorial boards of major journals in the field. Most importantly, our faculty are diligently developing and updating teaching content with their research expertise, bringing the state-of-the-art analytical training to students in all of our programs.
For more than 30 years, I have been a big fan of data-driven modeling and model uncertainty. As I have learned from my consulting experience that theory often do not work in reality if we just try to plug it in as a recipe. At Purdue, we are lucky to have excellent students who are apt to analytics, challenging and stimulating us to keep updating our curriculum to involve the latest research and experiences. I felt highly rewarded to learn that a student group were able to apply the retrospective analysis from my supply chain management course in their case competition and performed very well. Several students in our online global supply chain management program were able to find applications of the experimental design techniques they learned from my advanced manufacturing course at their workplaces. It is always exciting to see that the students apply our research ideas that we teach and make real impact in practice.
In the last couple of years, a rapidly increasing attention is given to the area on integrating data analytics into prediction and decision support in healthcare. Many students got interested in healthcare projects. I had the pleasure of working closely with both undergrad and graduate students on machine learning-based healthcare modeling and optimization. This is a joint project with IU Health, the largest hospital system in the state of Indiana. We apply machine learning and stochastic modeling tools to predict the daily workload in each of their 18 hospitals, which then provide decision support for their resource planning and staffing deployment plans. This project provides students hands-on experience on how data analytics could impact healthcare practice. At the same time, it strengthens my collaboration with hospitals, providing a great platform to scale up my research efforts.
We train our students to think about what works, what doesn't work, why it works, and how to make it work. Integrating the analytical skills with the understanding of business model and practical implication is the key to success. For example, when I shared with the class the protoproliferation solution I implemented at Hewlett-Packard, we first discussed different models and solution techniques. Then we analyze how the culture within the company has led to a selection of specific model and the specific method. When I introduced the supply cost modeling, we analyze why some of the commonly used feature selection methods may not work, and why data envelope analysis instead of regression may be more appropriate for custom-made products. The future leaders in analytics should be not just experts on modern software and techniques, but also the business architect. This is the unique strength we have in our faculty and our program, which make our students attractive to the recruiters.
With a vision of training the future analytics leaders in business, many of us are providing mentoring to students on internship projects through Purdue Discovery Park undergraduate research internship program. All of these projects require students to collect, comprehend, and analyze abundant amount of data to obtain descriptive understanding on the reality. This is a very hands-on training for the students to actually see how machine learning and other techniques they learn in the classroom can be converted to practical value. For example, in a project I co-advised last year, the students developed a comprehensive transportation model for the distribution network of a Bex hybrid, the third largest seed brand in the United States. The students were eager to see how the knowledge they learned from the classrooms work in the real world. I also gained inspirations for my own research projects in supply chain operations management.
Supply chain and operations management is an area in which Purdue University shows up consistently in major ranking systems, like the US News and World Report. Our brand name of high-quality analytical training certainly earns us the reputation. For example, GreatBusinessSchools.org, which has listed our BS major in Supply Chain Information and Analytics as number 3 in the 25 best supply chain bachelor's degrees, has particularly highlighted our training on students' problem-solving skills by stating that Purdue University stands apart from other programs by focusing on the data-driven education in students. At the graduate level, our MS in Global Supply Chain program shows up among the top 10 in various rankings. In its 2022 ranking of top 30 supply chain master's programs, PAT Research highlighted that the Purdue University Master of Science in Global Supply Chain Management program builds upon courses which develop contextual knowledge and problem-solving skills to provide a unique global work experience as a member of an international team. Analytics is the air we breathe, making research, practice, and education fully integrated and keeping our faculty, students, and practitioners in close interactions.
Next, you'll hear from Professor Mohit Tawarmalani. Mohit is the area coordinator of the business analytics area. He's a prolific researcher who studies topics both at the methodological level as well as in an applied context. He ensures that Cranard's business analytics area continues to thrive and deliver top-of-the-line research output while also ensuring that these ideas get translated into the classroom through a combination of adoption of state-of-the-art tools as well as emerging concepts in the field.
I'm so excited to tell you about the faculty and programs at Cranard that train our students to be trailblazers in the field of business analytics. There are 3 main ingredients that drive our student success. First, faculty who produce great research and bring it into the classroom. Second, our corporate partners who provide a rich playground of practical problems where our students develop original insights. Third, our students who are highly engaged participants. They seek out opportunities and actively involve themselves in case competitions and conference presentations. We have faculty who have terminal degrees in applied mathematics, statistics, engineering, and business. We think of business analytics as an interdisciplinary field. Our research faculty continue to collaborate with these colleges and remain abreast of advances in these disciplines. Meanwhile, our clinical faculty and lecturers bring rich industrial experience into the classroom and in guiding student projects. The faculty have an active and diverse research portfolio. We not only publish articles in top informed journals, but also in other highly reputed journals such as American Economic Review, Proceedings of National Academies of Sciences, and Annals of Probability. Our faculty are developing optimization algorithms, theory, and software, and devising new techniques in data science. We are exploring applications in business, economics, biostatistics, and sustainability. We have award-winning faculty at all stages of their career. While our senior faculty have received awards for their lifetime contributions, junior faculty are continually producing award-winning research and techniques. Our MS BAIM program curriculum focuses on 4 components: techniques, technologies, communication, and business knowledge. A design that was based on a review of industry reports, corporate feedback, and student experiences with the Walmart Data Dive. The Data Dive was organized by Business Information and Analytics Center, now called Krenicki Center for Business Analytics and Machine Learning, at Cranard, and drew students from various prominent business analytics programs across the country. Our MS BAIM program has been highly ranked since its inception. The faculty who teach courses such as optimization, machine learning, unstructured data analysis, and web data analytics have research interests in these domains. We will launch a new undergraduate major in business analytics and information management, which was formerly part of our supply chain information and analytics major. Besides our emphasis on the techniques and technologies, this program will also provide students cross-functional business knowledge. In addition, we want our students to think about topics such as ethics of data science and its impact on society. We will now hear from a few of our faculty regarding their research and the kind of experiences they bring into the classroom.
Hi, I'm Yanjun Li. My research field is combinatorial optimization and integer programming. The associated modeling and solution techniques are pervasive in actual business and economic applications, such as labor force planning models, transportation models, and healthcare models, etc. On my teaching side, I teach spreadsheet modeling and simulation to the master students. In the course, students learn how to build decision models in spreadsheets and how to solve them with simulation and optimization software, which is an important step in decision-making process. It's always my great pleasure to help students learn, practice, and make valuable contributions to their real-world projects.
My research interests are in non-convex optimization. As an example, energy-related global CO2 emissions were 36.3 billion metric tons in 2021. We show that process design guided by optimization can substantially reduce these emissions. I teach a class on optimization to our master's students. This class is designed from ground up to expose students to modern thinking in optimization. We discuss these advances while analyzing practical problems that are drawn from various application domains, including those where I have a research interest. Our alumni have used these methods to improve labor practices and to find process improvements in their organizations. We find that companies value and recruit from our programs specifically for this talent.
My research goal is to develop innovative machine learning tools for data science. I have used tensor methods to analyze 3D brain images in order to better understand which brain regions contribute to autism disease. I have also developed new reinforced learning methods for online decision-making problems, including dynamic pricing and personalized recommendation. Every year, I'm teaching the data mining courses for the BAIM students. Predictive algorithms like lasso, decision tree, random forest, gradient boosting are covered in this course. This course also contains a real cargo competition as the final project, where the BAIM students can quickly learn how data analytics works in industry.
As in a core course, our advanced business analytics for the BAIM program is set to bring the classroom closer to an operation room based on my industry practices, from serving as a data analyst to leading analytics functions in global reinsurance companies. While learning a mix of in-demand, underserved, and emerging analytics topics and methods, students also perform various practical exercises, such as how to customize modeling procedures as a way to derive needed hypothesis testing, or how to replace jargons like survival function with business-relevant terms for business conversation and presentations.
Our undergraduate, master's, and PhD programs ensure that we develop students who are passionate about analytics. Our courses teach conceptual thinking, use of tools, and applications to real-world problems. Students understand that analytics combined with an understanding of the implementation context result in real tangible change that can be documented. Our experiential courses provide opportunities for students to learn from applied contexts. Our centers enable larger scale funded engagements and opportunities that allow students to present to industry or government. We are committed to analytics for teaching, research, and engagement. Thank you.